Hi, my name is Yoo-Jin and my project's partner is Lauren, and we'll be presenting our final project, which is a voice command recognition system. Our motivation for this final project is to understand the fundamentals of speech recognition applications and implement robust algorithms such as DTW. Our project statement is to build a voice command recognition system that can distinguish a specific phrase no matter the unique voice, pitch, and tempo. Our system aims to recognize a query command as one of the 5 commands listed on the slide. Our goal was to create a system that could recognize the command with any person's voice. Thus, we recorded multiple people saying each command at different pitches and speeds. We randomly chose one person's audio samples saying each command normally as the reference templates. The remaining samples were used as query commands.
Now we'll go over our system design. First, a query and set of reference commands is read into the system. Second, the delta Mel Frequency Cepstrum Coefficients or delta MFCC features are extracted from the samples. Third, the reference database is constructed. Fourth, cosine similarity is calculated between the query commands delta MFCCs against those in the reference database. Fifth, subsequent dynamic time warping or DTW is implemented, which ignores tempo differences between the query and reference commands. Next, we computed the optimal path score, which represents the total dissimilarity of the cosine cost matrix. If the minimum cost corresponds to the correct reference command, the system outputs true. When deciding how to extract useful information from the time domain audio samples, we considered using chroma or MFCC features. While chroma features classify audio into 12 different pitches and take into account harmonics, MFCCs are more specific to human perceptible pitches and thus appropriate for our system. Next, we chose to use delta features since they take into account relative changes in pitch, which is useful for finding patterns in intonation, in questions, words, and different phrases. Why cosine similarity? It is normalized and not dependent on the magnitude of the matrices, unlike Euclidean distance, which is weighted. Finding optimal weights involves trial and error based on the accuracies we observed. For DTW, we prioritize the diagonal step sizes when finding the minimum distance path. In the case that the query and reference commands don't match, the blue line would be more jagged and the cost would be higher.
Let us now talk about how we evaluated our performance. We use accuracy as our main evaluation metric, namely total, command, and enunciation accuracy. The definitions of each of the accuracies are listed on the slide. Note that the enunciation accuracy refers to the accuracy across all the different tempos and pitch variations. Now, let us take a look at how our system performed. These are our results for the command accuracies using person J as a reference template and also across all persons. Some observations are that there is a higher accuracy for command 4 and 5, and the higher accuracy may be due to the fact that command 4 is a longer command, as well as command 5 being the only question in our list of commands. The specific intonation needed for a question may have helped our system easily distinguish it from other commands. These are results for the overall enunciation accuracies using person J as a reference template and also across all persons. Some observations that we see are that there seems to be a slight bias towards normally spoken audio files. This makes sense as the reference templates consist of normally spoken commands. The fast audio files are noted to have the lowest overall accuracy rate at 61.5%.
Based on our findings, we explored how the gender of the test subjects skewed command accuracies, with male voices recognized 67% of the time and female voices recognized 74% of the time. Challenges faced include establishing optimal weights and step sizes and selecting reference templates. We learned that the type of feature vectors significantly impact how commands are detected. To summarize, our current system shows great promise for command recognition, but could be improved by expanding the dataset and having an equal distribution between genders to represent more diverse human voices. Thank you for listening.